Let's get started on Module 5, Virtual Networks and Virtual Switches. There are two parts to this module, an introduction to virtual switches and configuring standard virtual switches. In this module, we will start out with a review of the physical network infrastructure, and then we will look at an introduction to virtual switches. We will look at virtual switch configuration, configuring vSwitch policies, configuring network interface card teaming for fault tolerance and load distribution, creating virtual switches, and adding virtual machines to virtual switches. Let's do a review of the physical network infrastructure. As you know, a physical switch is used to connect servers to servers, to connect PCs to servers, and connect everyone to the uplink, which goes to the router, which is our internet connection. There are four types of networks associated with an ESXi host: production, storage area network, management, and vMotion. Let's look at those four types of networks. The first type is a production network that everybody is pretty much familiar with. A production network is where the user's workstation is connected to a switch which connects to the ESXi host. A production network carries user traffic to the virtual machines. A storage area network connects the ESXi host to disk arrays, and it carries traffic from virtual machines to disk arrays. The third type of network is the management network, and this is where we have a separate network, a separate segment just for you and me, the network infrastructure engineers. And this connects our vCenter server and our vCenter client to the ESXi host. And you might say, an entire network just for the management? And the reason for that is because in case the production network is all congested and the storage area network is all congested, you and I can still get to the ESXi host to try to resolve the problem. And it is for the configuration of ESXi hosts. And a third type of network is a vMotion network. The vMotion network connects ESXi hosts to each other, and the purpose is to carry traffic between ESXi hosts, particularly the migration of virtual machines. Four types of networks associated with an ESXi host: production, storage area network, management, and vMotion. There are two configuration options. These four types of networks can be on four separate physical networks, or they can all be on the same network. Now, ideally, we have a separate network for each type of network. A separate physical network for the production network, a separate network for the storage area network, a separate network for the management network, and a separate network for vMotion. That's a good way to go, but the disadvantage is it tends to be a little expensive. And then the other end of the extreme would be all types of network traffic on one physical network, and that's cheaper, but it tends to lead toward network congestion, slows everybody down. So ideally, we have a separate physical network for each type of network traffic, but that's an expensive way to go. Most commonly, what we see is two types of networks are combined on each physical network. A typical configuration we see is the production network carries user traffic, but it is also used for the management network, where you or I would stand as the network infrastructure engineer. And then we have a second network which carries both storage area network traffic as well as vMotion traffic. So, review of physical network infrastructure. A switch connects servers to servers and PCs to servers and everybody to the uplink. There are 4 types of networks associated with an ESXi host: production, storage, management, vMotion, and there are 2 types of configuration options: a different physical network for each type of traffic, or they can all share the same physical network. All of these things which are true for a physical network infrastructure are also true for a virtual network infrastructure. So now let's turn to an introduction to virtual switches. A physical switch connects servers to servers, PCs to servers, and everyone to the uplink. A virtual switch does the same thing. This is an ESXi host. This box right here is supposed to be an ESXi host. In an ESXi host, we have multiple virtual machines, and in each virtual machine is an operating system and an application. The ESXi host will have at least one physical network interface card. That physical network interface card connects to the physical switch, which connects to the users at their workstation, and also connects to the uplink, which goes to the internet. So the question is, how do these virtual machines connect to this one physical network interface card? And the answer is we use a virtual switch. A virtual switch is a piece of software that connects virtual machines to virtual machines and connects virtual machines to the single physical network interface card, which connects to the switch, which connects to the users and to the internet. A virtual switch is a piece of software that connects virtual machines to each other and virtual machines to the physical network interface card. Here is another diagram that really shows the same thing. The gray box is the ESXi host. The blue box is the virtual switch. The virtual switch hooks virtual machines to each other and connects virtual machines to the physical network interface card. Let's examine the default virtual switch. Let's look at port groups, virtual machines, and network interface cards. If we select our ESXi host and go to the Configuration tab, and under Hardware, we click under Networking, we can see that this gray bar here is supposed to represent a switch turned up on its end. And this switch is connected to one physical network interface card, and it's connected to multiple virtual machines. Let's click on the properties for this virtual switch, and if we look at the virtual switch properties, we can see by default it has 120 ports, which means 120 virtual machines can connect to this virtual switch, and we can increase this number if necessary. If we look under network adapters, if we look at our network adapter and click on edit, by default it's configured to auto negotiate. However, we could configure this network adapter to run at 10 megabits per second in the case that we're installing an old network operating system such as NT server, which necessarily runs at 10 megabits per second. Typically, we leave it at auto negotiate, which typically is going to be 1 gigabit per second. VLANs, Virtual Local Area Networks. ESXi supports 802.1q VLAN tagging. Let's do a review of what's meant by a VLAN, a Virtual Local Area Network. In this simple single segment network, all of the computers are on the same segment. But what if I wanted to separate these computers from these computers? What I could do is purchase an additional switch, put half of them on one switch and half of them on the other switch. I could purchase an additional switch, put half of the computers on one switch and half of the computers on the other switch. And the reason I would create separate segments to separate computers is to limit the broadcast domain, to reduce traffic congestion, and for security. But the problem is, if we have only one physical switch, how can we separate the computers into separate local area networks? And the answer is a virtual local area network. A virtual local area network is where we have a single physical switch, and we logically divide it into logical subnets, whereby these computers are on VLAN 1 and these computers are on VLAN 2. And the reasons we do that is so it'll function as if there really are two physical separate network segments separating these machines from these machines. A VLAN logically divides a network into two logical segments to separate one group of computers from the other. ESXi provides VLAN support by giving a port group ID a virtual LAN ID. So let's do that. What we do is we create a port group, we add the virtual machines to the port group, and then we assign a VLAN ID. Let's assign a VLAN ID to a port group to segregate that port group. We go to the ESXi host. Under the Configuration tab, under Networking, we select our switch and we click under Properties. And you can see we have 4 different port groups on this one virtual switch. If we look at port group number 1 followed by Edit, we can assign it Virtual LAN ID 1. If we go to the second port group followed by Edit, we can assign it Virtual LAN ID 2. And each port group can be assigned a different Virtual LAN ID to segregate those virtual machines. The reason we do that is to create separate logical segments which act as if the machines are on separate physical segments. The purpose of a VLAN is to logically separate groups of virtual machines, to segregate traffic, and to limit the broadcast domain. And ESXi provides VLAN support by giving a port group a VLAN ID, meaning we create multiple virtual LANs on a single virtual switch. Now let's move on to Lesson 2, Configuring Virtual Switch Policies. We will look at configuring virtual switch security, traffic shaping, and network interface card teaming. If we go to our ESXi host and select the Configuration tab under Networking, under our virtual switch, we click on Properties. And under Properties, if we click on Edit, we see there are 3 tabs across the top: Traffic, Security, Traffic Shaping, and Network Interface Card Teaming. Let's start out with Security. Promiscuous mode is set to Reject. Now, if you were using a network monitor or a protocol analyzer to measure traffic, then you would typically select promiscuous mode to accept, and that allows a virtual machine to listen on all ports, which is what you would want to do if you were using a network monitor or a protocol analyzer. You would accept promiscuous mode. And then MAC address changes. Typically, we don't want MAC addresses to change, but there are certain applications such as the Microsoft failover server that does require that MAC addresses be assigned such that 2 virtual machines have the same MAC address. We typically don't want that, but there are some circumstances where we do want to accept MAC address changing, such as the case of Microsoft failover server. Traffic shaping. Suppose we have a situation where when we run Wireshark, we see that network utilization is really high. And if we run a program such as IO meter, we can see that one virtual machine is gobbling up all of the bandwidth. In that case, what we can do is implement a traffic shaping policy, which is also called bandwidth throttling. Traffic shaping is a mechanism for controlling virtual machine bandwidth. So initially, traffic shaping is disabled, but you would enable it if you wanted to limit the amount of bandwidth used by virtual machines. If I select status followed by enable, we can, assuming a bandwidth of 1 gigabit per second, we can limit the average bandwidth to 10% of the total bandwidth. If we click on help, we can see that average bandwidth establishes a number of bits per second allowed across a port over time. The average load, and the average load in this example we can set to be 10% of the total bandwidth. Now, burst size does allow virtual machines to use all of the bandwidth, but only for short periods of time, and that's called a burst. And in this example, a burst is 1 second. The reason we implement traffic shaping is to prevent one virtual machine from gobbling up all of the bandwidth. And then the third tab is network interface card teaming, and network interface card teaming requires that you have 2 network interface cards in an ESXi host. And there are 3 reasons why you might have 2 network interface cards in an ESXi host: fault tolerance, load distribution, or to connect to separate physical networks. You might have 2 network interface cards for fault tolerance. That way, if one fails, that's okay. The other one is available. So, this is called failover. Failover is when one network interface card fails, the other one takes its place. So, to configure for failover, we go to our virtual switch. We click on Properties. Notice you'll have to have 2 network interface cards in the first place. We click on Properties. We select Edit, and under Network Interface Card Teaming, it is currently configured for failover. If we look at the bottom, there is only one active adapter which is doing any work. The other adapter is a standby adapter, and it doesn't do anything until the first adapter fails. This is called using explicit failover. So if one network interface card fails, that's okay. The traffic is switched over to the second network interface card, and they call that failover. Failback. Failback is when the first network interface card stops working, and then traffic leaves the second network interface card and goes back to the first network interface card. We have an option here for failback yes, and you might think that you would want failback to be enabled. Failback means if the first network interface card starts working again, then the second network interface card goes back into the standby status, and then all traffic goes back to the first network interface card. But you might want to set that to no. The reason you might want to set failback to no is in case the first network interface card is intermittently bad. It's good and then it's bad. It's good and it's bad. And if you set failback to no, then that prevents flip-flopping between the first and the second network interface card, which can really draw on CPU utilization. You can also use 2 network interface cards for load distribution. If one network interface card runs at 1 gigabit per second, then 2 network interface cards can provide a throughput of 2 gigabits per second. In order to configure for 2 network interface cards to work in tandem to provide greater bandwidth, under the switch properties under network interface card teaming, where it says explicit failover, one is active and one is standby, we want to make them both active. So we take the lower network interface card and we click on move up, and now they are both active, and now both will be used for for virtual machine traffic, and that will increase our amount of bandwidth. If we look under load balancing, we see there are these load balancing algorithms. The default is route based on port ID, and there's another option that you can select, load balancing based upon IP hash. Let's look at those two methods. The default method is load balanced. It's a port-based load balancing method. It's a load balancing algorithm that tries to assign an equal number of VMs per each physical network interface card to distribute the load across the network interface cards. The disadvantage of that is that one virtual machine cannot send its traffic over two network interface cards simultaneously. So no one virtual machine can ever have 2 gigabits per second throughput. That's called the port-based load balancing method, and that's the default. It's not a bad way to go. However, the load balanced method of IP hash uses the link aggregation control protocol. That distributes traffic across multiple network interface cards, but the way it's different is a single virtual machine can send traffic across 2 network interface cards simultaneously, thus giving a throughput 2 gigabits per second for a single network interface card. The only catch is it requires that your switch support the link aggregation control protocol. The default is route based on port ID. If we select route based upon IP hash, that allows a single virtual machine to have 2 gigabits per second bandwidth. 3 reasons you might have 2 network interface cards in a single ESXi host: fault tolerance, load distribution. The third one is to connect to separate physical switches and separate networks. So let's look at the third method: creating additional virtual switches. There is already a default virtual switch. Why would you create another virtual switch? Or to put it another way, why have more than one virtual switch? The answer is to connect to multiple physical networks. In this diagram, we can see multiple virtual machines are connected to a physical virtual switch to connect to a single physical network interface card to connect to a single switch. However, if we had a second network interface card in that ESXi host hook up to a second switch, what we could do is add a second virtual switch. Thus, this virtual switch would connect these virtual machines to this physical network interface card and to this physical network, and this virtual switch would connect these virtual machines to this physical network interface card, which connects to this separate physical switch. Some virtual machines connect to one network, other virtual machines connect to another network. So let's do it. We will click on Add to create a new virtual switch. Click on Add, and it says connection type. We select virtual machine because it will carry virtual machine traffic. Virtual machine. Click on Next. What network interface card do we want to use? We're not going to use the first network interface card. We are going to use the second network interface card, network interface card 1, because that connects to the second switch, followed by Next. We give it a label such as Research and Development, followed by Next, and now we can see we've added a new virtual switch which is associated with a second network interface card. So there's the new virtual switch and there's the network interface card, but all of the virtual machines are still connected to the other virtual switch, which is connected to the other network interface cards. So we need to move these virtual machines from one virtual switch to the other virtual switch. To do that, we go to a virtual machine. To move a virtual machine from one virtual switch to the other, we go to the virtual machine, we right-click, we select Edit Settings. Under the Hardware tab, under Network Adapters, under Network Connection, we select the drop-down and we select the name of the new virtual switch that we just created. Click on OK. And then if we go back to the configuration tab, then we will see that the second virtual machine has been added to the second virtual switch, which is added to the second network interface card. You can use virtual switches to connect different virtual machines to different networks, and this allows us to isolate virtual machines. That is to say, these two virtual machines in the same physical machine can be connected to different physical networks, and they can be isolated from each other even though they're in the same physical machine. 3 reasons to have multiple network interface cards in the ESXi host: fault tolerance, load distribution, and the ability to connect to different physical switches. In summary, we started out this chapter by doing a review of the physical network infrastructure, and we saw that there were 4 different types of networks. Then we did an introduction to virtual switches, and we saw a virtual switch is a piece of software that connects VMs to VMs and VMs to the physical network interface card. We configured the virtual switch, and we configured virtual switch policies, including security, traffic shaping, and network interface card teaming. We saw that network interface card teaming can be used for fault tolerance or load distribution. We also saw that we could add additional virtual switches, and we could add virtual machines to those virtual switches, which could be connected to an additional network interface card. In summary, this concludes Module 5, Virtual Networks and Virtual Switches. Thank you very much, and have a nice day.